Cyclone.
In meteorology, a cyclone is an area of closed, circular fluid motion rotating in the same direction as the Earth. This is usually characterized by inward spiraling winds that rotate anti-clockwise in the Northern Hemisphere and clockwise in the Southern Hemisphere of the Earth. Most large-scale cyclonic circulations are centered on areas of low atmospheric pressure. The largest low-pressure systems are cold core polar cyclones and extratropical cyclones, which lie on the synoptic scale. According to the NHC glossary, warm core cyclones such as tropical cyclones and subtropical cyclones also lie within the synoptic scale. Mesocyclones, tornadoes and dust devils lie within the smaller mesoscale. Upper-level cyclones can exist without the presence of a surface low, and can pinch off from the base of the tropical upper tropospheric trough during the summer months in the Northern Hemisphere. Cyclones have also been seen on extraterrestrial planets, such as Mars and Neptune. Cyclogenesis describes the process of cyclone formation and intensification. Extratropical cyclones form as waves in large regions of enhanced mid-latitude temperature contrasts called baroclinic zones. These zones contract to form weather fronts as the cyclonic circulation closes and intensifies. Later in their life cycle, cyclones occlude as cold core systems. A cyclone's track is guided over the course of its 2 to 6 day life cycle by the steering flow of the Cancer or subtropical jet stream. Weather fronts separate two masses of air of different densities and are associated with the most prominent meteorological phenomena. Air masses separated by a front may differ in temperature or humidity. Strong cold fronts typically feature narrow bands of thunderstorms and severe weather, and may on occasion be preceded by squall lines or dry lines. They form west of the circulation center and generally move from west to east. Warm fronts form east of the cyclone center and are usually preceded by stratiform precipitation and fog. They move polluted ahead of the cyclone path. Occluded fronts form late in the cyclone life cycle near the center of the cyclone and often wrap around the storm center. Tropical cyclogenesis describes the process of development of tropical cyclones. Tropical cyclones form due to latent heat driven by significant thunderstorm activity, and a warm core. Cyclones can transition between extratropical, subtropical, and tropical phases under the right conditions. Mesocyclones form as warm core cyclones over land, and can lead to tornado formation. Water spouts can also form from mesocyclones, but more often develop from environments of high instability and low vertical wind shear. In the Atlantic Basin, a tropical cyclone is generally referred to as a hurricane, from the name of the ancient Central American deity of wind, Huracan, a cyclone in the Indian Ocean and parts of the Pacific, and a typhoon in the Northwest Pacific region.
Structure.
There are a number of structural characteristics common to all cyclones. A cyclone is a low-pressure area. A cyclone center, often known in a mature tropical cyclone as the eye, is the area of lowest atmospheric pressure in the region. Near the center, the pressure gradient force, from the pressure in the center of the cyclone compared to the pressure outside the cyclone, and the force from the Coriolis effect must be in an approximate balance, or the cyclone would collapse on itself as a result of the difference in pressure. Because of the Coriolis effect, the wind flow around a large cyclone is counterclockwise in the Northern Hemisphere and clockwise in the Southern Hemisphere. Cyclonic circulation is sometimes referred to as contra-solemn. In the Northern Hemisphere, the fastest winds relative to the surface of the Earth therefore occur on the eastern side of a northward-moving cyclone and on the northern side of a westward-moving one. The opposite occurs in the Southern Hemisphere. The wind flow around an anticyclone, on the other hand, is clockwise in the Northern Hemisphere, and counterclockwise in the Southern Hemisphere.
Formation.
Cyclogenesis is the development or strengthening of cyclonic circulation in the atmosphere, a low-pressure area. Cyclogenesis is an umbrella term for several different processes, all of which result in the development of some sort of cyclone. It can occur at various scales, from the microscale to the synoptic scale. Extratropical cyclones form as waves along weather fronts before occluding later in their life cycle as cold core cyclones. Tropical cyclones form due to latent heat driven by significant thunderstorm activity, and a warm core. Mesocyclones form as warm core cyclones over land, and can lead to tornado formation. Water spouts can also form from mesocyclones, but more often develop from environments of high instability and low vertical wind shear. Cyclogenesis is the opposite of cyclolysis, and is an anti-cyclonic, high-pressure system, equivalent which deals with the formation of high-pressure areas, anti-cyclogenesis. The surface low has a variety of ways of forming. Topography can force a surface low when dense low-level high-pressure system ridges in east of a north-south mountain barrier. Mesoscale convective systems can spawn surface lows which are initially warm core. The disturbance can grow into a wave-like formation along the front and the low will be positioned at the crest. Around the low, flow will become cyclonic, by definition. This rotational flow will push polar air equatorward west of the low via its trailing cold front, and warmer air with push poleward low via the warm front. Usually the cold front will move at a quicker pace than the warm front and catch up with it due to the slow erosion of higher density air mass located out ahead of the cyclone and the higher density air mass sweeping in behind the cyclone, usually resulting in a narrowing warm sector. At this point an occluded front forms where the warm air mass is pushed upwards into a trough of warm air aloft, which is also known as a trough. Tropical cyclogenesis is the technical term describing the development and strengthening of a tropical cyclone in the atmosphere. The mechanisms through which tropical cyclogenesis occurs are distinctly different from those through which mid-latitude cyclogenesis occurs. Tropical cyclogenesis involves the development of a warm core cyclone, due to significant convection in a favorable atmospheric environment. There are 6 main requirements for tropical cyclogenesis: sufficiently warm sea surface temperatures, atmospheric instability, high humidity in the lower to middle levels of the troposphere, enough Coriolis force to develop a low-pressure center, a pre-existing low-level focus or disturbance, and low vertical wind shear. An average of 86 tropical cyclones of tropical storm intensity form annually worldwide, with 47 reaching hurricane typhoon strength, and 20 becoming intense tropical cyclones, at least Category 3 intensity on the Saffir-Simpson hurricane scale.
Synoptic scale.
The following types of cyclones are identifiable in synoptic charts.
Surface-based types.
There are 3 main types: surface-based cyclones, extratropical cyclones, subtropical cyclones and tropical cyclones.
Extratropical cyclone.
An extratropical cyclone is a synoptic scale low-pressure weather system that does not have tropical characteristics, being connected with fronts and horizontal gradients in temperature and dew point, otherwise known as baroclinic zones. The descriptor extratropical refers to the fact that this type of cyclone generally occurs outside of the tropics, in the middle latitudes of the planet. These systems may also be described as mid-latitude cyclones due to their area of formation, or post-tropical cyclones, where extratropical transition has occurred, and are often described as depressions, or lows by weather forecasters and the general public. These are the everyday phenomena which, along with anticyclones, drive the weather over much of the Earth. Although extratropical cyclones are almost always classified as baroclinic since they form along zones of temperature and dew point gradient within the westerlies, they can sometimes become barotropic late in their life cycle when the temperature distribution around the cyclone becomes fairly uniform with radius. An extratropical cyclone can transform into a subtropical storm, and from there into a tropical cyclone, if it dwells over warm waters and develops central convection, which warms its core. One intense type of extratropical cyclone that strikes during wintertime is a nor'easter.
Polar low.
A polar low is a small-scale, short-lived atmospheric low-pressure system, depression, that is found over the ocean areas polluted of the main polar front in both the northern and southern hemispheres. Polar lows are cold core, so they can be considered as a subset of extratropical cyclones. Polar lows were first identified on the meteorological satellite imagery that became available in the 1960s, which revealed many small-scale cloud vortices at high latitudes. The most active polar lows are found over certain ice-free maritime areas in or near the Arctic during the winter, such as the Norwegian Sea, Barents Sea, Labrador Sea and Gulf of Alaska. Polar lows dissipate rapidly when they make landfall. Antarctic systems tend to be weaker than their northern counterparts since the air-sea temperature differences around the continent are generally smaller. However, vigorous polar lows can be found over the Southern Ocean. During winter, when cold core lows with temperatures in the mid-levels of the troposphere reach 45 DEGC, 49 DEGF, move over open waters, deep convection forms which allows polar low development to become possible. The systems usually have a horizontal length scale of less than 1,000 kilometers, 620 miles, and exist for no more than a couple of days. They are part of the larger class of mesoscale weather systems. Polar lows can be difficult to detect using conventional weather reports and are a hazard to high-latitude operations, such as shipping and gas and oil platforms. Polar lows have been referred to by many other terms, such as polar mesoscale vortex, Arctic hurricane, Arctic low, and cold air depression. Today the term is usually reserved for the more vigorous systems that have near-surface winds of at least 17 meters per second.
Subtropical.
A subtropical cyclone is a weather system that has some characteristics of a tropical cyclone and some characteristics of an extratropical cyclone. They can form between the equator and the 50th parallel. As early as the 1950s, meteorologists were unclear whether they should be characterized as tropical cyclones or extratropical cyclones, and used terms such as quasi-tropical and semi-tropical to describe the cyclone hybrids. By 1972, the National Hurricane Center officially recognized this cyclone category. Subtropical cyclones began to receive names off the official tropical cyclone list in the Atlantic Basin in 2002. They have broad wind patterns with maximum sustained winds located farther from the center than typical tropical cyclones, and exist in areas of weak to moderate temperature gradient. Since they form from initially extratropical cyclones which have colder temperatures aloft than normally found in the tropics, the sea surface temperatures required for their formation are lower than the tropical cyclone threshold by 3 degrees Celsius, or 5 degrees Fahrenheit, lying around 23 degrees Celsius. This means that subtropical cyclones are more likely to form outside the traditional bounds of the hurricane season. Although subtropical storms rarely have hurricane-force winds, they may become tropical in nature as their course warm.
Tropical.
A tropical cyclone is a storm system characterized by a low-pressure center and numerous thunderstorms that produce strong winds and flooding rain. A tropical cyclone feeds on heat released when moist air rises, resulting in condensation of water vapor contained in the moist air. They are fueled by a different heat mechanism than other cyclonic windstorms such as nor'easters, European windstorms, and polar lows, leading to their classification as warm core storm systems. The term tropical refers to both the geographic origin of these systems, which form almost exclusively in tropical regions of the globe, and their formation in maritime tropical air masses. The term cyclone refers to such storms' cyclonic nature, with counterclockwise rotation in the Northern Hemisphere and clockwise rotation in the Southern Hemisphere. Depending on their location and strength, tropical cyclones are referred to by other names, such as hurricane, typhoon, tropical storm, cyclonic storm, tropical depression, or simply as a cyclone. While tropical cyclones can produce extremely powerful winds and torrential rain, they are also able to produce high waves and damaging storm surge. They develop over large bodies of warm water, and lose their strength if they move over land. This is the reason coastal regions can receive significant damage from a tropical cyclone, while inland regions are relatively safe from receiving strong winds. Heavy rains, however, can produce significant flooding inland, and storm surges can produce extensive coastal flooding up to 40 kilometers, 25 miles, from the coastline. Although their effects on human populations can be devastating, Tropical cyclones can also relieve drought conditions. They also carry heat and energy away from the tropics and transport it toward temperate latitudes, which makes them an important part of the global atmospheric circulation mechanism. As a result, tropical cyclones help to maintain equilibrium in the Earth's troposphere. Many tropical cyclones develop when the atmospheric conditions around a weak disturbance in the atmosphere are favorable. Others form when other types of cyclones acquire tropical characteristics. Tropical systems are then moved by steering winds in the troposphere. If the conditions remain favorable, the tropical disturbance intensifies, and can even develop an eye. On the other end of the spectrum, if the conditions around the system deteriorate or the tropical cyclone makes landfall, the system weakens and eventually dissipates. A tropical cyclone can become extratropical as it moves toward higher latitudes if its energy source changes from heat released by condensation to differences in temperature between air masses. From an operational standpoint, a tropical cyclone is usually not considered to become subtropical during its extratropical transition.
Upper-level types. Polar cyclone.
A polar, subpolar, or Arctic cyclone, also known as a polar vortex, is a vast area of low pressure which strengthens in the winter and weakens in the summer. A polar cyclone is a low-pressure weather system, usually spanning 1,000 kilometers, 620 miles, to 2,000 kilometers, 1,200 miles, in which the air circulates in a counterclockwise direction in the Northern Hemisphere, and a clockwise direction in the Southern Hemisphere. In the Northern Hemisphere, the polar cyclone has two centers on average. One center lies near Baffin Island and the other over northeast Siberia. In the Southern Hemisphere, it tends to be located near the edge of the Ross Ice Shelf near 160 west longitude. When the polar vortex is strong, westerly flow descends to the Earth's surface. When the polar cyclone is weak, significant cold outbreaks occur.
Tudsell.
Under specific circumstances, upper cold lows can break off from the base of the Tropical Upper Tropospheric Trough, TUT, which is located mid-ocean in the Northern Hemisphere during the summer months. These upper tropospheric cyclonic vortices, also known as tudcells or tudlows, usually move slowly from east-northeast to west-southwest, and generally do not extend below 20,000 feet in altitude. A weak inverted surface trough within the trade wind is generally found underneath them, and they may also be associated with broad areas of high-level clouds. Downward development results in an increase of cumulus clouds and the appearance of a surface vortex. In rare cases, they become warm core, resulting in the vortex becoming a tropical cyclone. Upper cyclones and upper troughs which trail tropical cyclones can cause additional outflow channels and aid in their intensification process. Developing tropical disturbances can help create or deepen upper troughs or upper lows in their wake due to the outflow jet emanating from the developing tropical disturbance cyclone.
Mesoscale.
The following types of cyclones are not identifiable in synoptic charts.
Mesocyclone.
A mesocyclone is a vortex of air, 2.0 kilometers, 1.2 miles, to 10 kilometers, 6.2 miles, in diameter, the mesoscale of meteorology, within a convective storm. Air rises and rotates around a vertical axis, usually in the same direction as low-pressure systems in both northern and southern hemisphere. They are most often cyclonic, that is, associated with a localized low-pressure region within a supercell. Such storms can feature strong surface winds and severe hail. Mesocyclones often occur together with updrafts in supercells, where tornadoes may form. About 1,700 mesocyclones form annually across the United States, but only half produce tornadoes.
Tornado.
A tornado is a violently rotating column of air that is in contact with both the surface of the Earth and a cumulonimbus cloud or, in rare cases, the base of a cumulus cloud. They are often referred to as twisters or cyclones, although the word cyclone is used in meteorology, in a wider sense, to name any closed low-pressure circulation.
Dust devil.
A dust devil is a strong, well-formed, and relatively long-lived whirlwind, ranging from small, half a meter wide and a few meters tall, to large, more than 10 meters wide and more than 1,000 meters tall. The primary vertical motion is upward. Dust devils are usually harmless, but can on rare occasions grow large enough to pose a threat to both people and property.
Waterspout.
A columnar vortex forming over water connected to a cumuliform cloud. Similar to a tornado but usually weaker.
Steam devil.
A gentle vortex over calm water or wetland made visible by rising water vapor.
Other planets.
Cyclones are not unique to Earth. Cyclonic storms are common on Jovian planets, such as the small dark spot on Neptune. Also known as the Wizard's Eye, it is about 1/3 the diameter of the Great Dark Spot. It received the name Wizard's Eye, because it looks like an eye. This appearance is caused by a white cloud in the middle of the Wizard's Eye. Mars has also exhibited cyclonic storms. Jovian storms like the Great Red Spot are usually mistakenly named as giant hurricanes or cyclonic storms. However, this is inaccurate, as the Great Red Spot is, in fact, the inverse phenomenon, an anti-cyclone.